Okay, so this is rational expressions. What the heck does rational mean even? Well, a rational number can be written as a fraction. This is important. I want you to actually write that. Rational number can be written as a fraction. Why? Because you know what? This is an ACT term. They can say which of these is a rational number. And if you didn't know, you're like, well, I don't know. Does it seem sane? Like rational, often we refer to in conversation as like, well, he's a rational guy. He's rational. He like understands logic. That's not what these are at all. They have to be able to be written as a fraction. Can everything be written as a fraction? No. But most numbers can be written as a fraction. If I start with the number 7, what's its fraction? 7 over 1. What if I start with 3.5? What's its fraction? 3.5 over 1 is not okay because you have to have whole numbers. So there you go. It's 3.5. So what's the fraction for that? You're getting closer. 7 over 2. There you go. Okay, good. So that's a fraction. So if you can write it as a fraction, you're good. And some of the ones people don't think you can write as fractions are repeating decimals, but you can. If it repeats, you can make a fraction for it. I'll give you an example. 1/9 is 0.1 repeating. Okay? So 0.272727, it keeps repeating forever. That is a rational number because I can write it as a fraction. You want to take a guess? It's not 27 over 9. Not 27 over 100 because that it would stop. It wouldn't repeat. Take a shot at this. What? Nope. All right. I'll give you this hint. 0.2 repeating would be 2/9. 0.7 repeating would be 7/9. Come on. You're closest so far, but that's not it. What? You're closer. There it is. Say it louder. Yes, 27 over 99. Okay, so that is the fraction for this number. So if it can be written as a fraction, it's called rational. All right. And if you're thinking, but Mr. Server, when I put that in my calculator, it says 2727278 or 2727223 or something like that. The 2 turns into a 3. It's just a rounding thing. Okay, so it does repeat forever. Yes? Does this reduce to 3/11ths? Okay. All right, I'm going to break it up. 9 times 3 is the top, and 99 would be 3 times 33. So let me see.
You can take 9 out of it.
9 times 11, there we go. Sorry. 9 times 11. That's what I should be looking for. Those 9s cancel. 3/11ths, very good. Okay. So this is rational numbers because they can be written as a fraction. Now, 2/9 was 0.2 repeating. What do you think 5/9 is? 0.5 repeating. How about 6/9? How about 7/9? You know, you're getting a little bit bored of this, but what's 8/9? It's coming up to something interesting. So how about 0.9 repeating? I am asking 9 out of 9. So it must be, follow the pattern, 0.6, 0.7, 0.8, 0.9 repeating.
No.
Because 0.9 repeating is equal to 1. Which doesn't just round to 1. I know not 0.99 would round to 1. 0.99999.9 repeating is 1. It's equal to 1. 1/3 is 0.3 repeating. Would you agree with that? 2/3 is 0.6 repeating. You going to believe that?
Yeah.
Add them together and see what you get.
Yeah, but 3 divided by 3
is equal to? Oh yeah. Okay. So what is this equal to?
0.999.
But it should be.
So you're saying we can just round it to 1. No, it is 1. 0.9 repeating isn't really close to 1. It's 1.
Wait. No, wait.
I'll give you another one. I'll give you an algebraic proof. I'll let you give your argument in a second. N is 0.9 repeating. You can't say anything's wrong with that. It's just I'm saying N is going to be this decimal, 0.9 repeating. Okay? Would you agree if I multiply it, thank you very much, by 10, that 10 times this would be 10N, and 10 times that would move the decimal over one spot, and it would become 9.9 repeating. Are you with me so far?
Yes.
Have I broken any rules of math when I multiplied by 10 on both sides? All right. Next, I'm going to subtract N from both sides. Is it breaking any rules of math to do that? You're just saying that because you don't want this to work. I am going to subtract something from both sides. But wouldn't you agree we've always said you could subtract something from both sides? Just like we can add something to both sides. All right? So I can subtract something from both sides. I'm not trying to trick you here. This is just a fact. I'm trying to help you understand. So if I'm subtracting an N from both sides, if N is really equal to 0.9 repeating, because it says so right there, then do you get I can subtract 0.9 repeating instead of N because they're the same thing?
Yes.
So I'm going to subtract a 0.9 repeating right here because they are the same thing as each other. N is 0.9 repeating. So I'm going to go 10N minus an N, and please don't say it's 10. 10 N's, 10 Nerf balls minus a Nerf ball makes 9N, 9 Nerf balls. 9N is equal to, oh, isn't that just going to cancel off that? 9N equals 9. Solve it. What's N equal to? 1. 0.9 repeating is 1. They're equal.
Wait, hold on. How come you can subtract the N if you're multiplying it by 10?
You can subtract any number you want as long as you do it to both sides. I just chose to subtract N instead of subtracting 0.9 repeating. They're the same thing. I mean, this and this are the same thing. It says so right here. All right. So if you feel like it's a little bit less than 1, is that how you still feel? It's a little bit less than 1? Okay. How about this? How much less than 1 is it?
Oh, you can't say it.
If you can't say it, maybe it really isn't less than 1. As soon as you say an amount, I'll say no, it's smaller than that.
3 divided
It's not 0.01. Come on. It's 0.00001, except if that's if you wanted to stop, but you can never stop.
How is this? 4 divided by 4 was that 1? I can keep going all day.
It's true. It's 0.9 repeating. It's just that, you know, the calculator can't put unlimited 9s there, so anytime that was going to say 0.9 repeating, what would it say? Exactly. That's why 1 plus 1 is 2, and so is 0.19 repeating plus 0.9 repeating. It's also equal to 2. All right. So anyway, that's a good topic in the topic of rational numbers, because rational numbers can be written as fractions. All right. So there's going to be old TV shows coming up. Anybody know this one? Urkel is not the name of the TV show. Family Matters. All right. And just going way back, I hope you remember how to add things that have common denominators. That's super simple. 2/5 plus 1/5 would be 3/5 because they had a common denominator. What if they don't? That's on my top 20, and so you've been practicing it all year. Should be a piece of cake. We make them have a common denominator by going like this. What's a good common denominator? 12. So I got to multiply this by 4, and I got to multiply this by 3. And then I get 8/12 and 3/12. 8/12 and 3/12 makes 11/12. Think you could handle that? That's just adding fractions. Why am I talking about that? Because, again, rational numbers can be written as a fraction. So we got to be good at fractions. So this one, you can multiply this and say 2/10, but what would have been smarter to do first? Cross off the 2's because those 2's can cancel. And then what's the answer even better? 1/5. All right, do the same thing on the other side. Do some canceling that you would be smart to do. And then figure out the answer. Here's the way I like to do this and the way I wish they taught it when you first learned it. That 9 can be replaced or factored into 3 times 3, and then you can do what? Cancel the 3. Doink, doink. What you probably were taught, and I used to teach it this way too, I just didn't know why it would be better to teach it another way. What I used to do is go, 3 goes into 9, how many times? 3 goes into 3, how many times? But that's, so many people don't get it that way. I think everybody'd get it if it's like, how do you write a 9 as a multiply? It's called factoring. I think everybody'd get that that's only could be 3 times 3. And then you go, oh, 3's can cancel. Because you have to teach kids that those kind of things cancel anyways. So anyway, that's the way I wish you had learned it. But maybe you can do it in that way now. 3/10. All right. Oh, the show was called Sister Sister? All right. Dang, I don't think I even learned that one. I knew about this one though. Barney. Do you remember when there was a big hoo-ha over Tinky Winky or something like that? The one with the triangle on top of his head. Oh, that's Teletubbies. You're right. Okay, sorry about that. Sorry about that. This was just the one where everybody had the dumb little song about Barney and tying him to a tree or something like that. I don't know.
I actually know what you're talking about.
So anywho, on the divide fractions, just a quick reminder, it's smarter to flip and multiply. So we go 2/5, change it to times what? 2 over 1. Notice, did both of them flip? No, just the second one flips. So do the other one yourself and see what you get. Flip it. Flip it good. 21 over 22. Raise your hand if you had that one right. Okay, good. On to the next one. Ooh, what show was this? I have no idea. Strawberry Shortcake. Are you embarrassed to know that? Just a little bit? Okay, anyway. We just had a great conversation last hour about Pokemon too. So that was a thing back in the day. Don't act like you never were interested in that when you were little. Anyway, 15 over. I know some of you weren't ever into it, but you at least knew about it. All right, 15 over 2. What is that the same as? Well, we have to make him into a mixed number or the other kind. Is this a mixed number or is this an improper? Improper. And I hate the word improper because it sounds like wrong. Like if I said your behavior was improper, you would say, oh, I was wrong. This is not wrong to write it this way. It's totally okay to have 15 over 2. We do that all the time in higher level math. But if you want it as a mixed number, you can say 7 goes in there, and then how much is left? Yes. And another way to say that is, I could break this into 14 halves plus 1 half. Does that help you see that it's 7 and 1/2? I like to think of it this way, because that's 7, then that's the half, so there we go. That's how it makes 7 and 1/2. What would this one break into? What and what? How many sevenths and how many sevenths? Yeah, 7 sevenths and 1 seventh. So what's the answer? 1 and 1/7. All right. This can be thought of as a whole bunch of halves. How many halves make 3? 6 halves plus 1/2. Do you get how that helps? Because what's the answer? 7 halves. And you can do the shortcut, which is 3 times 2 plus 1. It's just sometimes people don't know what the heck they're doing. So this is a shortcut. If you know the shortcut, it is that times that plus that. So it's 4 times 8. 8 times 4 is 32. Plus 7 makes 39/8. If you want to do it that way, great. If you want to say to yourself, how many eighths is 4? Well, it's going to be 8 eighths is like 1. So it'd be 4 times that big. 32/8 plus 7/8 is 39/8. Either way, you get 39/8. All right, moving on. Full house, yes. And you saw this in the top 20 a bazillion times, so hopefully you're good at it by now. Instead of divide by 3/4, you should times by 4/3. It's essentially the same as that other one that had a divide sign in between, because that's what a fraction bar means. Then I'm gonna break this up. You argue that later. This 4, it turns into 2 times 2, and then I can cancel. Why did I do that? Because now the answer is reduced, and it is 2/3. Good. Moving on. All right. You're looking ahead. Cheater. All right. So A is not a fraction. I've often said that fractions play nice with other fractions. In other words, if this was a fraction, it would make this problem easier. And then you'd notice, oh, it's one of those fraction over a fraction deals, really. So now I can do A over 1 times what? C over B. Very good. And I changed a divide by B over C into times C over B. And this would be what? AC over B. All right, so we're getting your fraction skills strong so that you can even, oh, yep, it's Seinfeld, yep, definitely. Okay, would you try this one, please? It's got a not common denominator. I'll give you a hint. It's the same process. You multiply by something here and here, and here and here. That way you'll have a common denominator. Give this a shot. Your answer will be like AD plus BM over DB or something like that. Give it a shot. I'm not saying that's the right answer. I'm saying it'll all be letters. Pause for a second while you figure this one out. Okay, this is where this stuff starts getting a little harder. Pay attention. First thought, what's a good common denominator? Well, what you always did before, if you had two numbers like this, is you would say multiply the denominators, like in this case 35, right? So what would be a good denominator for this one? B times D. So your answer is going to be B times D or D times B. It doesn't matter. You can reverse them, just like 3 times 5 is the same as 5 times 3. That's a good denominator. Well, how am I going to get there? Well, this one's already got a D, so I have to multiply it by B. And if I multiply by B on the bottom, you have to multiply by B on the top, and then the same on the other side. If this one's already got a B, so we have to times it by. All right, go ahead and finish the deal if you haven't already, and write me an answer. This is where it gets to be actually higher algebra level. Otherwise, it was actually like 4th grade level, so maybe 3rd. All right, so that and that are the same thing. People that don't know what they're doing, add them together on the bottom. Think about it. If you had 1/7 plus 5/7, if they're the same on the bottom, do you say that it's 6/14? No. What would the answer to that one be? 6/7. Notice you keep the denominator the same. You don't actually change the denominator. It's just sevenths. So in this case, we don't change dB plus dB. We just say the denominator is dB or BD. This can be reversed. It doesn't matter. The tops need to be added then, dA plus CB. If you said BC, does it matter? No, you can reverse them. Raise your hand if you had this answer. Okay, good. I helped with that one though, so let's try one. M over A plus R over 7. Add those together. You'll need a common denominator. Multiply by the right thing. M over A plus R over 7. One of the topics on the ACT, that's a biggie, is handling fractions over fractions, and then when you throw in variables in your fractions over fractions. And that's basically what we're attempting to do over these next few days, is get you ready for hardcore fractions, not just 2/3 anymore. It might be a plus, well, this, m over a plus r over 7. You got to be able to put those together. All right, did you figure out that a7 or 7a would be a good denominator? Good. So then I got to get this to be a 7a, so I times by a. Now I got to get this to be a 7a, so I put a 7 there. And then they have the same denominator, so the denominator is 7a. Or a7, it doesn't matter, although technically, when you have a number, you should really put it first. So 7a is better than a7. On the top, we can't actually add these because they are not like terms. So we just leave them as 7m plus ra or ar, doesn't matter. Raise your hand if you had that one right. Okay, good. All right, you're hanging with these tough ones. Let's see if you can handle an even tougher one. Here's the hint. First, you get this all added together. Then, instead of dividing by this fraction, you're going to change this to multiply by, flip it. So that second part of this is going to be easy. Try to find that common denominator up here because you can't just slap these together. They have to have a common denominator. So add them first. And the other thing is, don't parentheses have to be done first? And this has parentheses, so get it done. This has parentheses, but it's already done. There's nothing to do in there. So that defaults to, that has to be first. All right, I'll pause for a second while you give that a try. All right, I'm back from the recording there, or from the pause. I'm going to times by I on top and bottom here, and k, sorry, on top and bottom there. That way they both have a ki denominator. So you should have said kh plus ji or ij, doesn't matter, over ki. And then I'm not going to rewrite this whole thing the wrong way. I'm going to, instead of saying divide by this, I'm going to say times by what? K over j, yes. Now here's what really will separate the men from the boys and the ladies from the girls. Did anybody notice there's something that could cancel? Aha. What would cancel? All right, so I'm going to start one thing at a time. Do you guys all agree that there is a k on the bottom and there is a k on the top? All right. This is part of a multiply problem, and this you could say is k times 1. Do you get then I can cancel those k's? But, and it's a big but, you cannot cancel those j's. Why not?
You gotta cancel the one from the top of the box.
You can't cancel those j's.
Oh, it's addition.
They're in an addition problem. This is part of an addition problem, so you may not do that. No canceling that. It's a big deal. Remember me saying if you can factor it, you should. And then if you have to get things factored, you can cancel them. This, is there anything in this and that could be factored out? No. And therefore, you cannot cancel those j's. It's a very common mistake, but something, honestly, I bet you half the kids in here would assume we could cancel those j's. If this whole thing is just being times by 1, which is right there, it can stay the same, right? And then what's the common denominator now? Well, it's not really a common denominator question because it's a multiply question. When you're multiplying, you just multiply across the bottom and multiply across the top. So the top's already done because we times it by 1, it stays the same. What's the bottom? That's not a J. That's an I. That's a J. I know they both have curvy things on them, but one of them's an I, one of them's a J. Okay, so IJ is your denominator. So the top is KH plus IJ, or JI, doesn't matter, all over IJ, or again, JI. I'll pause for a second while you process that. The top just got multiplied by 1. You get that? Denominators just get multiplied because this is a multiply problem. It is not an add problem. When you're multiplying like this, then you just multiply across the bottom. Okay, move on to this one. This one's got some numbers and some variables. Which one is it? The what? The Wiggles? Seriously? Wow, I don't even. I never saw. My kids weren't the right age. You were obsessed with the Wiggles. Oh my gosh. Okay. That's awesome. Okay. All right. I want you to start by adding those ones on top. That should be a blast from the past. That's like 4th grade. You can do that. Find a common denominator, add them. Then this one, I want to give you a hint because otherwise I don't think anybody will get it right. So I want to give you this hint. I know you all know how to do 9 times 3. That's the easy part. That part right there, to do that part I just circled in black, you have to remember that that y isn't a fraction until you make it 1. And you should make it 1 because I said fractions will only play nice with other fractions. So that y isn't going to work well until you make it a fraction, and then you'll know whether you should put it on the top or the bottom. Okay, see if you can do this. This has a lot of steps. There's like 1,200 places to make a dumb little mistake. This is a typical ACT type question. Can you rearrange this all and simplify it down and cancel and stuff? I'll pause for a minute while you give that one a try. This is about as hard as it gets. All right, let's see what you got. Who thinks they actually have a decent shot at having this one? All right. 4 people with no confidence problems. This is good. All right. Maybe some of you just know you're wrong and don't want to say yes. For the top, at least, how about the top? How many of you feel like you added the top right? Yes. All right. Yeah. That's one of the top 20 skills. You should have it down by now. And if you don't, shame on you. You come in the mornings and get some help. All right. Common denominator. Well, I could say 24, and it'll work fine, because 6 times 4 is 24. That's a good way to do it. But you could also reduce it if you want to something smaller, 12. If I want to make it 12, it's not too tough to make them both into 12, and I'm going to do it that way. And this will be times 3 and times 3. Now, those of you that made it 24, don't fret. It'll all work out the same as long as you reduce your answer. So this will come out to 12 and 12, so my denominator is 12. This will come out to 9 and 10, so it's 19 twelfths. If you had something that was twice that big, then that means you just didn't reduce yet, and you should. Okay, now I'm taking that whole thing, and instead of dividing by this thing, I'm going to instantly change it to times that thing flipped. Now I got to figure out what this thing is. Would you agree that this thing was 27 on top over 12xy over 4? Because the y, since it's over 1, should go on top with that little group. Then that's really 27 times, and fractions play nice with other fractions, 27 over 1 times 4 over 12xy. Now I've got a little canceling I can do. Notice this 12 can be factored into 4 times 3. And then the 4's can cancel. Why can that 4 cancel? Because it's part of a multiply problem. Why did I change that 12 into a 4 times 3? So I could cancel the 4's. Okay, because I just did a divided by that, so I flipped and multiplied. Okay, so now, all done, 27 over 3xy is what the bottom simplifies to. So now I'm going to flip and multiply that. And so now it's 19 twelfths times 3xy over 27. And then I can't emphasize this enough. You've got to look for times when you can factor things like, oh, this 27 could be 9 times 3. And that way, the 3's can cancel. Yes. And now, all said and done, 19xy over 12 times 9 is going to be 90, 108. Did anybody actually have it right? 5 people. Nice job. Okay. That was tough. It's circled on the board there. 19xy over 108. Okay. That is enough practice. Now let's get to the worksheet for today. Oh, one more thing. Do you remember me saying if you can, if you can, okay, it's Dora. If you can factor it, you should. This can be factored. This can be factored. Once you got it factored, do you remember how you can cancel things like that? All right. This can factor to x plus 3 and x minus 1. On the bottom, it can factor to 3x. And let me think. I think it's going to be x minus 1, and this is going to be plus 2. I'm going to double check that. Outside, inside. Nope, that's the exact opposite of what I want. So I put an x plus 1 here and an x and a minus there. There, I just did your factoring for you to save some time. And then if you can factor it, you should. I factored it so that I could cancel stuff. Cancels, cancels. All right. So your homework for tonight is complex fractions worksheet 1 through 9. Given the short amount of time you have left in here today, I will keep it reasonable. You keep getting done. I just want you to do the odd ones. Today was kind of an odd day, so do the odds. 1, 3, 5, 7, 9. All right. Okay, that's all I got for you for today.